Hi guys, so what we're going to be talking about today is prime factorization. So prime factorization means that I'm looking for all prime numbers that I can multiply together to be able to get an original number. So one of the first things we need to figure out is what's a prime number? So a prime number is any number that has just two factors, one and itself. So if I have any number that has two factors. So only two factors, one and itself. So we can think about what are different examples of prime numbers. So if I'm looking at just prime numbers, I'm going to start with 2. Prime is arguably a prime number, but it's just 1 times 1. So most of the time we don't add it. So we typically start with 2, 3, 4. Can I multiply only 4 by 1 times 4 to get to 4? No. So I can do 2 times 2 to get to 4. So that's not a prime number. So my next prime number is 5, 7. What about 8? No. 9. Nine's odd, but no. So if you notice, every number after 2 is going to be odd, but it's not every odd number. So actually, the next prime number is going to be 11, 13, and then it just keeps going. It's 17, etc. So then those are the prime numbers that we can be utilizing when I do prime factorization. So once again, a prime number is any number that is only two factors to get to it. So if I multiply 1 times itself, it's the only way I can multiply together to get to these numbers. So then what is a composite number? So a composite number is just going to be the opposite. So a composite number is any number that has more than two factors. So if a number has to be either prime or composite, it's going to be the other numbers. And once again, 1 is kind of arguably a prime, but we don't typically use it. So we typically skip it, and I'm looking at only positive numbers. We're not looking at negatives. And I'm going to start looking for numbers that have more than two factors. So I am going to start 2 is a prime, 3 is a prime. So our first composite number that we're going to be looking at is 4. 5 is a prime, so that's not up there. 6. 7's prime, so that's not going to work. So then I have 8, 9, 10, 11's prime, 12. So you get an idea. All these numbers have more than one set of factors. So 4, I can multiply 1 times 4 or 2 times 2. 6, I can multiply 1 times 6 or 2 times 3. 8, I can multiply 1 times 8 or 2 times 4. So all of these have multiple ways to multiply together to get them as a solution. So what we're going to be doing is we're going to be breaking our numbers into prime numbers at the very end. We are allowed to use some composite numbers, but then we're going to break down our composite numbers to all primes because every number can be listed with just prime numbers when I multiply them together to get to that number. So we're also going to need one other term for this, and we're going to need to understand exponential form again. So if you remember, exponents is when I have a base number with a small number above it that is a multiplication problem of consistently multiplying the same number together. So if I have 2 times 2 times 2 times 2, I can write that by condensing it and making it smaller by putting an exponent. An exponent is that little number up in the corner. So my base number is going to be the number that I see. So I see 2's. So my base number is going to be a 2. And then my exponent is going to be how many times I see the 2. So I see the 2 1, 2, 3, 4 times. So then my exponent is going to be 4. So the exponential form of 2 times 2 times 2 times 2 is 2 to the 4th power because I have 2 4 times. So we can do this again, and I can look at it, and I'm going to do something with a different number. So let's say I have 3 times 3 times 3. I'm going to ask myself, what number do I see? And that's going to be my base number, the big number. So I see a 3. And then my exponent is how many times I see the 3. So in this case, I see the 3 1, 2, 3 times. So then my exponent is going to be 3. So 3 to the 3rd power. So why is that useful? So what we're going to do is we are going to be looking at some numbers, and I'm going to be breaking them apart into primes. And then once I find the primes, we are going to be putting them as a multiplication problem. And then we're going to shorten the multiplication problem into prime numbers with exponents. So we're going to look at how to find the prime factorization of a few different numbers. So I'm going to always start with one number, and I'm going to ask myself, what are any two numbers that I can multiply together to get to that number? The only factor pairs I want to avoid are 1 in itself, because if the only factors are 1 in itself, it's already prime, and I don't have to do prime factorization. So we're going to start with 50. So I need to ask myself, what are any two numbers that I can multiply together to get to 50? It does not matter what you start with. Start with whatever numbers you first think of. So if I look at 50, the first two numbers that I think of are 5 times 10. That is not the only option. You could also do 2 times 25. Those are different options that will get us to the same answer. So I'm going to do 5 times 10 because I know any number that ends in a 0 is divisible by 10. So I'm going to start by making a factor tree. So I'm going to take 2 lines off of this 50, and I'm going to write the factors below it. So I'm going to write 5 on one side, 10 on the other. And that means that these two numbers that are connected to 50, if I do 5 times 10, I'll get to 50. So now I need to ask myself, are either of these numbers prime? And we just made a list of prime numbers. So is 5 or 10, are they on my prime list? One of them is. 5 is prime. So I'm going to circle 5 so I know that that is the end of that branch of the tree. 10 is composite. So that means it has more factor pairs. So then I'm going to stop and I'm going to say, what are two numbers that I can multiply together to get to 10? I do not want to use 1 times 10. So I only have one other option, and I have 2 times 5. So I'm going to make another branch off, and I'm going to write the two factors that equal 10. So 2 times 5. I need to then ask myself, are either of those numbers prime? Is 2 prime? Yes, the only factors for 2 are 1 times 2. So I'm going to circle the 2. Is 5 prime? It is. We've already established that 5 is prime by circling it over here. So I'm going to circle 5. So I now know that 2, 5, and 5 are the prime numbers. I have no more composite numbers to break apart. So these are the final numbers that I'm going to use. My next step is I am going to write a multiplication problem by ordering the numbers from smallest to largest. So my first number is going to be 2, and I'm only using the prime numbers. So 2 times 5 times 5. So if I did this right, if I multiply 2 times 5 times 5, I'm going to get back to 50. So 2 times 5 is 10. 10 times 5 is 50. So I know I did it right. So another step that you might see is that if you need to put it in exponential form. So I'm going to ask myself, do I have multiples of any number? I have 2 5s. So I could shorten this and put it in exponential form. I only have 1 2, so I'm going to leave the 2, but then I'm going to write the 5 as an exponent. So remember, my base is the number I see, so I'm going to write 5. And then my exponent is how many 5s I have. So 5 times 5, so I have 2. So I'm going to have an exponent of 2. So I know my prime factorization for 50 is 2 times 5 times 5, or 2 times 5 to the second power. Okay, so we're going to do the same thing. We're going to do it with the 8 now. So I'm going to move my picture. There we go. So we're going to do with 8, and I'm going to change my pen color just so we can see the difference. So what do I need to start by asking myself? What are 2 factors besides 1 and 8 that I can multiply together to get to 8? So I can multiply 2 times 4. So I'm going to start by making 2 branches, 2 and 4. Then I need to ask myself, is 2 or 4 prime? 2 is prime, so I'm going to circle the 2. 4 is composite, so that means I need to break it apart into 2 other numbers. So I need to ask myself, what are 2 factors that I can multiply together to get to 4? That is not 1 times 4. So those 2 factors are 2 times 2. So then I need to ask myself, is 2 prime? We've already said yes. So I'm going to circle the 2's. Once I have circles on the end of every line, I know that I'm done and I have all prime numbers, and that's our goal. So now I'm going to write it as a multiplication problem with each of the numbers that are circled from smallest to largest. They're all 2, so it doesn't really matter the order. I'm going to just write this as a multiplication problem. So 2 times 2 times 2. But I have repeated numbers. So if it wants you to write it as exponential form, I can now shorten this and write it as an exponent. Our base is the number I see. So what number do we see? We see a 2. So the 2 is going to be my big number. It's my base. And my exponent is how many times I see the 2. So 1, 2, 3. So I have an exponent of 3. So my prime factorization of 8 is 2 times 2 times 2, or 2 to the third power. Okay, so let's apply this. So where is this useful? So this is useful when I'm doing least common multiple and greatest common factor. I can use this to help us find the least common multiple and greatest common factor of 2 or more numbers. So I'm going to use the same numbers for least common multiple and greatest common factor to show how you can utilize this to find LCM and GCF without doing our factor rainbow and without doing our multiples and making a list. So I'm going to start by finding the prime factorization of each number. I do not want to put this in exponential form though. Okay, we are going to leave this as a multiplication problem that we list out. So I am going to do it for 12. So I need to think to myself, what are 2 numbers that I can multiply together to get to 12? So there's multiple different options that you can use. I am going to pick 3 times 4. I could also have picked 2 times 6, and it would not be wrong. You will get the same final answer. It does not matter which 2 factors you pick as long as they are factors of the previous number. So now I'm going to ask myself, is 3 or 4 prime? 3 is prime, so I'm going to circle it. 4 is composite, so I need to break apart 4. So what are 2 numbers I can multiply together to get to 4? That is not 1 times 4. 2 times 2 would be my only option. I'm going to circle them because we now know that 2 is prime. And I have a circle on the end of each of my lines so I know I'm done. So my prime factorization for 12 is 2 times 2 times 3. For this, I do not want to put them in exponents, so I'm going to leave this as 2 times 2 times 3. So now I'm going to move over to 20, and I'm going to find the prime factorization for 20. What are two numbers I can multiply together to get to 20? It ends in 0, so I know I can multiply 10 times something to get there. Or you could also pick 4 times 5. Either one will work. You will get the same answer. So I'm going to start with 2 times 10. So I'm going to make my branches. 2 times 10 will give me 20. Is either of these numbers prime? Yes. 2 is prime. So I'm going to circle the 2. 10 is composite. So I'm going to break that down. What two numbers can I multiply together to get to 10? 2 and 5. I already know that 2 is prime, so I'm going to circle it. Prime numbers get circled, composite numbers get broken down. So 5, is it prime? Yes. The only two factors of 5 are 1 times 5, so I'm going to circle it. I have no more numbers I need to get broken down, so I'm done circling. I'm going to now write this as a multiplication problem. 2 times 2 times 5. Okay, so now that I have my prime factorization for both numbers, the 12 and the 20, what I want to do is I want to stack them on top of each other so I can compare them. So I'm going to change color so we can write this a little bit easier. Okay, I'm going to stack them on top of each other. I'm going to just do it over here because I have the most space. It does not matter which one you put on top. Typically, I put the longer one on top, but that's just a personal choice. So I'm going to put 2 times 2 times 3, and then 2 times 2 times 5. Okay, so I like to think for least common multiple, I like to think of lazy numbers. I'm looking across. So I'm trying to find the largest amount of the same number across the rows. So since I have 2 in both rows, in the top line and the bottom line, I'm going to look to figure out which one has the longer amount of 2's. In this situation, they both have 2, so it doesn't really matter. But if one had 2 and one had 3, I'm going to pick the 3 line. And so I am going to circle all of the numbers that make the longer list. So this one, I'm going to just circle the top. I'm going to circle both 2's that are on the top. Every single individual number that I see, so in this one, I see 2's, 3's, and 5's. Every single one needs to be included. I'm just picking the row that has the most. So now I see a 3, so I'm going to circle the row that has the most 3's. I only have 3 in the top row, so I'm going to circle the 3. And then the bottom has 1 5. There's no 5's on the top, so I'm going to circle the 5. So to find the least common multiple, I'm going to pick the most of each individual digit, so 2, 3, and 5 in this case, and I'm going to set it up as a multiplication problem. So 2 times 2 times 3 times 5. So 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So my least common multiple of 12 and 20 is 60. So I want to do one more example. I don't have it built in, so give me 1 second. Okay, so we're going to do another example with 16 and 24. So I'm going to break apart each number into the prime factorizations. I'm going to start with 16. What are two numbers I can break apart 16 into by multiplying them together? There are multiple different options. I'm going to do 4 times 4. So I'm going to start 4 times 4. Is either of those prime? No. So I'm going to continue to break both of them apart. So I'm going to start with 4, and I'm going to have 2 times 2. They are both prime, so I'm going to circle them. 4, once again, is going to be 2 times 2. I'm going to circle them. So for 16, my factors are 2 times 2 times 2 times 2. Okay, now I'm going to do 24. I'm going to break it apart into 2 factors. Once again, there's multiple different options. I'm going to do 4 times 6. 4 and 6. Are either of those prime? No, so I need to break apart both of them. They're both composite. So 4 is going to be 2 times 2. I'm going to circle them. They're both prime. 6 is 2 times 3. Both 2 and 3 are prime, so I'm going to circle both. Now I'm going to set up a multiplication problem from smallest to largest number. So I'm going to have 2 times 2 times 2 times 3. So 2 times 2 times 2 times 3. Now that I have the prime factorization for both numbers, I am going to now stack them on top of each other so I can find the least common multiple. So I'm going to write it down here because I have the most room. 2 times 2 times 2 times 2. That is 16. Then I'm going to take this one for 24, and I'm going to do 2 times 2 times 2 times 3. I'm going to ask myself, what digits do I see? I see a 2 and I see 3s. So I'm going to look for the row lazy. I'm looking long, L for lazy. So I'm laying down, looking long. Okay, so I'm looking for the row that has the most 2s. My top row up here has 1, 2, 3, 4 2s. My bottom row has 1, 2, 3. So I need to use the top group of 2s. So I'm going to circle all of these. And then I'm going to say, where are my most 3s? I have no 3s on top and I have 1 3 on bottom, so I'm going to circle the bottom 3. I'm going to use every number that I circled in my list for least common multiple. So now I'm going to multiply it out. 2 times 2 times 2 times 2 times 3. All of these 2's equal 16. Or 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So you could either do 16 times 3 or start at the 3 times 2 and work your way down. But my least common multiple of 24 and 16 is 48. Okay, so let's look at using this prime factorization in regards to greatest common factor. So we're going to still do the same thing, but we are going to use the same process exactly, but now we're going to break it apart a little bit differently to find greatest common factor. So I'm going to start again by finding my prime factorization of 12 and 20. So I'm going to start with 12. The last time I did 3 and 4, so I'm going to do 2 and 6 this time to prove that it's the same thing. So I'm going to start with 2 and 6. 2 and 6. One's prime, one's composite. Which one's prime? The 2. So I'm going to circle the 2. 6 is composite, so I need to continue to break it down. 2 times 3 will give me 6. So those are my factors. I need to ask myself, are either of those prime? They're both prime, so I'm going to circle them. So then my prime factorization for 12 is 2 times 2 times 3. I'm going to do the same thing with 20, but last time I did 2 times 10. So I'm going to do the same thing now, but I'm going to do it with 4 times 5 to prove that I'm going to get the same factors. So I'm going to have 4 and 5. 5 is prime, so I'm going to circle it. 4 we know is composite, so I'm going to break it apart into 2 times 2. So if you notice, it didn't matter which numbers I started with, I still end up with the same prime factorization, which is 2 times 2 times 5. Okay, So now we need to find our prime factorization, or find our greatest common factor using prime factorization. So I'm going to set it up the same way I did before. I'm going to stack them on top of each other. Typically, I like the longer one on top. Both of these are the same size. It really honestly doesn't matter. So I'm going to put them on top of each other. So 2 times 2 times 3, 2 times 2 times 5. Okay, for greatest common factor, I like to think of G for giant. I'm looking tall-wise, okay? I'm trying to find pairs tall-wise. The only time I circle it is if I have one number on bottom and I have a pair on top. And once I use the digit, I cannot use it again to make another pair. So for this one, I'm going to look at this 2 and say, do I have a 2 to match it up at top? I do. So I'm going to circle it tall-wise, G for giant. I'm going to look again to see at this 2, do I have a 2 on top? I do. So I'm going to circle them. It has to be a different set of 2s. You can't use the same 2 twice. Now I have a 5. Do I have a 5 on top? No. Do I have a 3 on bottom? No. So I do not circle them. Now I'm going to only use one number from each circled group. So I have a 2 here. So I'm going to have 2. And I have a 2 from this group. I'm not using all the 2s I am circling. They are a pair now. I'm only choosing one number from each pair that I circled. So I have 1 2 for this group and 1 2 for this group. So I would multiply 2 times 2 together. So my greatest common factor of 12 and 20 is going to be 4. Let's do a second example. Okay, sorry. And so we're going to do the same numbers we did before, which we did 16 and 20. So I'm going to start by writing 16 and 20. Or 24, I apologize. 16 and 24. So I'm going to start by doing my prime factorization for 16 and 24. So we already know what it is, but I want to prove it to you the same using different numbers. So before I used 4 times 4, so now I'm going to use 2 and 8. So I'm going to break it apart. 2 times 8. I know 2 is prime, so I'm going to circle it. 8 is composite, so I'm going to continue breaking it down. 2 times 4. 2 is prime. I'm going to circle it. 4 is composite. I need to break it down. 2 times 2. Both 2's are prime. I'm going to circle both. I'm going to now write it as a multiplication problem. So 2 times 2 times 2 times 2. I'm going to do the same thing for 24. Okay, I did 6 times 4 last time, so let's do 3 times 8. 3 and 8. 3 is prime. 8 we just found out over here. So we have 2 and 4. 2. Oop, 4 is not. I need to break it down. 2 times 2. Now I need to list them from smallest to largest. So this one is going to start with the 2's. So I'm going to have 2 times 2 times 2 times 3. I'm going to line them up again, stacking them on top of each other. I'm going to change my pen color so we can see the difference. I'm just going to do them kind of in the middle since I have the most room. So I'm going to stack up this one on top of this one. So I'm going to do 2 times 2 times 2 times 2. Then 2 times 2 times 2 times 3. So now I'm looking vertically to find my matches. So I have a pair of 2's here, a pair of 2's here, and a pair of 2's here. I do not have a 2 to match with this, so I do not circle it. I cannot use any of these 2's again, and I do not have a 3 to match. So I'm just going to take 1 2 from each of these lines. So 2 times 2 times 2. So my greatest common factor of 16 and 24 is going to be 2 times 2 is 4, 4 times 2 is 8. So my greatest common factor is 8. I hope this helps. If you have any questions, please let me know. Have a great day.